Hello, welcome to From Scratch, Season 1, Episode 1. My name is Toby, and this is a show for junior software developers. I would like to help you grow into your career. Software development has a really long learning curve. An experienced and advanced developer can be many times more productive than an inexperienced and beginning developer. For you, as a junior developer, if you want to advance in your career and do well, then what you want to solve for is how to continue to climb that learning curve. Recently, I have been lamenting the rise of very structured frameworks, and what I see is these structured frameworks, they have a very, very specific prescribed way of doing things, and as a result, users of the frameworks and learners are simply following instructions, and I feel like that takes away opportunities for junior developers to grow and to work on their software design skills. So From Scratch is a bit of a reaction to that. In the first season of this show, I plan to build a 2D game from scratch using Canvas and TypeScript. This is not meant to be a course. In an interview where jazz pianist Marian McPartland interviewed also jazz pianist Bill Evans. Marian is a teacher, and she asked Bill for some advice for her students. And Bill started out playing something simple on the piano. She described what she was doing, was explaining as he played, but he kept adding to his pattern that he was playing, and as he explained more and more, things got more and more complex, and it wasn't very long before they launched into a full-blown improvised solo. And when they were done, Marian asked Bill, "Wow, that's quite advanced for the beginning student." And Bill's answer to that was, "Well, knowing where you're going is half the battle." So this is a demonstration of where you're going. The things I'm going to focus on, and the things I would like you to focus on as you're watching, are refactoring and object-oriented design. And I'm going to be making use of some object-oriented design patterns. And when I do, that's when I want you to pay really careful attention. The prerequisites for this are JavaScript. In order for you to get the most out of this, you should live and breathe JavaScript. It would be very, very helpful for you to already have an understanding and familiarity with classes and objects. Canvas, it would be nice if you had some experience in the past working with the Canvas API, although it's not absolutely required. I'm going to be using TypeScript and Webpack in these videos. I will introduce them as I go, and without further ado, let's get started. I'm going to start from scratch. I have a very, very minimalistic Webpack setup, which is set up to support TypeScript, which at the moment is my language of choice. I have grown very familiar with TypeScript to the point where I prefer it over JavaScript now. And the day when that happened, that was kind of surprising to me. But anyway, so this project has these dependencies, which are TypeScript, Webpack, and the TS loader, which is Webpack's TypeScript loader. And other than that, it's just pure JavaScript and DOM manipulation. I'm going to be using the Canvas API to draw things on the screen and build a game from scratch. In my setup that I created ahead of time, I said that the entry point of the application was going to be this app.ts file in the source folder. So I'm going to create that same structure. Just created the source folder, and now I'm going to create the app.ts file. I think at this point I'm ready to get started, and I'm going to run the Webpack dev server to get my application started. And that is a huge amount of output, more than I expected, but that's fine. So now that means we have the application running at localhost 8080. So let's write some code. If you haven't noticed, I'm using Visual Studio Code, which is sort of like the free and community version of Visual Studio. It's highly recommended, especially if you're using TypeScript. But a lot of people use it even if they're not using TypeScript. So anyway, so I'm gonna start writing some TypeScript. I'm just gonna console.log to begin with, and you can see that console.log message hello world coming out in the console. So I know this code is working. All right, now that I have this, I want to write a Canvas game. So what do I need first? I need a canvas. So let's create a canvas. I'm gonna set the HTML within document.body, and I'm gonna use the template string literal. Let me make the font slightly bigger for you to see. So these upticks is the ES5 template string literal, and it allows multi-line strings. And this is how I like to write HTML code sometimes. I'm gonna read this error message as saying this string is not assignable to the type of HTML element. So this is where TypeScript is helping me out with mistakes that I make. So document.body is an HTML element, and I can't change it to something that's not an HTML element. In this case, I'm trying to change it to a string. So I made a mistake. What I meant to do was set the inner HTML of this element, and now it lets me do that. So I'm gonna set it to the inner HTML. So like, for example, if I put an header here, it should render faithfully to what I told it to render. But that's actually not what I want. I'm gonna create a canvas tag, and I'm gonna give it a width and a height. I'm just gonna draw a little border around it. So that's our canvas. See if it printed out the canvas, and it did. Okay, so that worked. Now I'm gonna get a graphics context. I'm gonna name it as CTX, and the way you get a context, a graphics context, is via the method canvas.getContext, I think, right? Maybe I forgot it. I'm gonna Google it. Yeah, it is getContext. Why didn't you help me out there? Oh, I know, because it didn't know that this canvas variable is actually HTML canvas element, because get element by ID returns a HTML element, which could be any kind of HTML element. It could be a div, it could be a header, whatever. In TypeScript, I could make it more intelligent by telling it explicitly that this is in fact a canvas element. So I know there's a definition for the canvas element and every single tag in the HTML universe. So this is typecasting. I've casted the return value of get element by ID to an HTML canvas element, so that this guy now knows it's a canvas element. Okay, now I have a graphics context. Once I have a graphics context, I can start drawing on it. One of the first things I can draw is maybe a rectangle. I can see the argument it expects. So TypeScript giving me the signature of this function, which I can see it needs X, Y, and W and H. I'm gonna assume W is the width and H is the height. So maybe it should do that. And it did. I'm gonna draw it a smaller width and smaller height and see it change. And if you want to change the color, what you do is you say ctx.fill let me Google it. I don't quite remember. It probably has an example. MDN has really good documentation on this. It's fill style, and the auto completion helps me out here. I'm gonna fill a orange rectangle. Okay, and there it is. Cool. So let's get down to it. I want to build a game. And actually I got some game assets. I got this Ninja Girl graphic set or sprite set. I'll show you what it looks like. This is what Ninja Girl looks like when she's idle, and for each pose there's actually a series of images which allows you to do a animation. When she's jumping, you kind of flip through these images to create this animated effect, and that is pretty cool. I want to give credit to the authors of this. I found it in Free Game Assets, which is called Game Art 2D, and this is Ninja Girl. There's also a boy ninja, as my boys would like to say. There is a robot and zombies. We might be introducing the zombies soon. Other than the characters, there's also tile sets, which would be come in handy later. This is really a great way to start building games, and there are other websites that provide free assets, free game assets like this as well. So I'm using Ninja Girl, and for now I'm just going to take one of these images. I'll take the idle 000 and put her on the canvas, and I can reference the URL. I'm gonna draw it. I'm gonna get rid of this fill rectangle code. Use the canvas to draw this ninja guy. So the API wants a number of arguments. This argument list is kind of hard to read, but let me explain it to you. So the first argument is an image, and this is really confusing because an image can be a number of different types. This vertical bar, that's the pipe character, and in TypeScript, when you have one type, pipe character, another type, pipe character, yet another type, that means that parameter can be an object or a value of any one of these types, and in this case there are 4. There's HTML canvas element, or it could be an HTML image element, or it could be an HTML video element, or it could be an image bitmap. Any of those would do. And then we need a destination. I think that's the coordinate, the X coordinate and the Y coordinate where we want to draw the image. In order to get one of these things, we have to create it. I'm gonna choose the HTML image element. This is actually you can create an image element using just new image. Let me hover over it. Yeah, it is same as an image tag, or I should say the img tag. So when you do new image, you get an image element, and we're gonna set its source to the image URL. Like that. So now we get this image element, we can draw it. I'm gonna draw it at 0, 0, which means it should render at the top left corner of the canvas here. And that did not work. Let's do a little debug session here. I can see that the image was gotten correctly, so I don't believe that was the problem. See, we even got the image returning. Oh, I know why. I remember now. I have come across this problem before. At the time when I'm drawing this image has not been fetched yet. So I need to wait for the image to be fetched before I draw the image on the canvas. So to illustrate, I'm gonna wait until the image has been loaded to draw the image. And that does it. Okay, cool. This is not ideal though, in terms of how I want to structure this code. I don't want to, I may have multiple images and then I have to wait for all the images to load. And in a game setting, what you would normally do is, as you're changing the state of the world, you just re-render the game over and over and over and over again. And you use the request animation frame method in order to do that. And so let's go ahead and do that. I'm gonna take this code here. Visual Studio Code with TypeScript, and probably in other languages too. Maybe it even works for JavaScript, I don't know. Has a really cool feature. Is a automatic code refactoring. So you can select a section of code, right click on it, and say refactor. You can tell it to extract to a function in the global scope. Now it's going to ask you for the name. I'm going to call this function render. And then boom, it has extracted that line of code into a function. Normally, you probably do it with a larger chunk of code than a one-liner, but I am very happy with this. So I have a render function, which I'm going to say that's going to render the scene of the game. And then I'm gonna just keep calling this render function over and over again. And the way I'm gonna set that up is request animation frame function. I'm gonna pass the render function to that function. And the job of request animation frame is to call the function that was passed to it, in this case render, as soon as the other JavaScript in the browser has finished executing. To keep this cycle going, I'm gonna, after drawing an image, and later on we're gonna add more code here too, like here. But after drawing it, I'm going to immediately request a redraw. So this is like a recursive function that keeps calling itself over and over and over again. And sometimes we call that the main loop. This just loops. This acts like a loop that just keeps drawing the scene over and over again. And this will allow us to successfully draw a Ninja Girl. So the reason this works, whereas previously it didn't, is because we're just gonna continue redrawing it. So even if in the first render call, in the first draw image, Ninja Girl image wasn't fetched, in later frames it would have been fetched. And that's how we get it onto the canvas. Okay, now, so the Ninja Girl is way too big, way too big. We're gonna draw a Ninja Girl smaller. Let me look at what's the size of the Ninja Girl image. It's 290 by 500. Maybe divide by 3. It's 96.66. I'm gonna say the width, I'm gonna change it to 96.66, and the height, I'm gonna divide by 3 too, so 166.66. And now Ninja Girl is smaller. I'm gonna move her up. So I'll make a girl width and a girl height. Maybe I can extract variable with this. Let me see. Refactor, extract constant in global scope. Yes, that's exactly what I want. Thank you, Visual Studio Code. Okay. So I'm gonna call this guy girl width. Now extract this guy as girl height. Bam. Okay. Okay. Save it. Make sure it still works. Now the girl's legs are chopped off. I'm gonna make it so her legs are not chopped off. And the way I'm gonna do that is by doing a calculation. So we know the height and width of the canvas. I'm gonna create constants for that. I think I can put her in the right place if I subtract the height of the canvas by the height of the girl. Yeah, and that's where I want to start rendering her. It should be right around here. First 100, I'm gonna make it 0 to put her flush against the beginning of the canvas. And then the second number is, I want it to be the canvas height minus girl's height. There, and now we're not chopping off her legs anymore. Very cool. All right, so now that I have that going, the first thing I want to do is get her to jump. We do have a set of images where ninja girl is jumping in the air. And I do want to make use of these animations. Let's get the jumping working, and then we'll get this animation going as a second step. So now how are we gonna get jumping working? This guy and this guy are essentially the X and Y coordinates of Ninja Girl. What we could do is vary these values as the game progresses. What I'm gonna do is take this value and extract again. I'm gonna refactor. Okay, a constant, not what I want. I want a variable, so I want a let. So I'm just gonna do this one myself. So I'm gonna call this girl X, and I'm gonna set that to 0. There we go. And then the girl Y is gonna be this guy. So that's a variable extraction step. Now I'm ready to make changes to this. Maybe I make it so that when the user presses the up arrow key, it's going to jump. To do that, I'm going to set up a key press event listener. So if there's a key down event, then we're going to, let's for now just console.log something. I can tell TypeScript that's it's a keyboard event, and from the keyboard event I have access to a key code. So I'm gonna see if that works. If I type in something using my keyboard, it should print out the key code of the key that I typed in. So I type, yeah, so for example, spacebar, that's 32, enter has a key code of 13. The key we want is up arrow, and up arrow has the code of 38. If you know of a better way to get at these key codes, please tell me. I'm gonna write a line of comment here that says up arrow. What are we gonna do if the user press up arrow? Well, we could change the Y position, which controls the up and down position of the Ninja Girl. I can just increase that. All right, let's see what that does. Okay. Oh no, actually increasing its Y would actually move it down. And also we didn't erase the existing girl. So yeah, that's kind of weird. Yeah, so it turns out the coordinate system of the canvas is 0 on the top, and as it goes down the number increases. So it's like 0, 10, 20, etc. What I wanted to do is decrease its Y to make it go up, and now it goes up. But now the problem is we need to erase the trail of the girl in the frame. And the most common way of doing that is just erase the entire canvas before you draw the scene every single time. Let's just do that. Black. Okay, so yeah, so now the Ninja Girl is moving up. And now that I'm thinking about, maybe I should make the fill color some tone of black. Maybe like, I don't know, 080808. It's like a grayish black kind of thing. Because it is a ninja. And ninjas only come out at night. Super pitch black, but grayish black. Maybe something like that. Okay. So Ninja Girl can go up, but that's unnatural. You're not supposed to just suspend in midair like that. We want Ninja Girl to go up and then drop back down like the way a natural object would. At least trying to simulate the law of gravity in some way. So I think what we need to do is to make this girl Y variable change over time by a certain offset, and we may have like another variable that represents the speed of the girl, speed X and speed Y. I'm gonna try to see if I can cheat and do with a more straightforward way. Yeah, let me try to just make her go up and then down in a without acceleration first. So maybe like for 10 frames, she's gonna go up, and then for another 10 frames, she's gonna be going down. To do that, we're gonna need a state going up. I'm just gonna call it up, or it's going down. Okay, and put that in the comment. And there's, you know, in TypeScript, there's a way to write that type too, but I'm not gonna do it for now. So at the beginning, the girl is in the idle state. I'm gonna call this variable girl state. I'm gonna change the girl state to up if we have this up arrow. And then inside this render method, maybe render isn't going to be a good name for this anymore. So I'm gonna maybe call this frame, execute frame, run frame, game loop, just call it game loop. Rename symbol game loop. And another thing I really like about VS Code is you can rename symbols and it'll go through all of the code and rename that same variable in all the various places for you. I renamed render to game loop because I want to add other code in here. That's not just to do with the rendering. So this code is dealing with rendering, but I'm gonna add additional code here which deals with updating the object at every frame of the game. So I'm gonna call this, I'm gonna say if the girl's state is up, then we're going to increase the girl's Y value. Subtract 2 pixels. Oh, now she just keeps on going infinitely. Okay, that's cool, right? And we can tweak how fast she goes up by tweaking the sort of the delta of how much to increase by each time. And in fact, we could change this delta too, and that's how we get the acceleration effect. But for now, let's get her to come back down. Let's say if she reaches a certain apex, the top of the canvas is 0, right? And the bottom of the canvas is canvas height 250. So this is 0, this is 250. 200 is probably here, 100 is probably here. Let's say maybe she reaches 50. Then we're gonna make her go back down. And how we're gonna make her go back down? We're gonna change the state to down. If it is less than or equal to 50, we're gonna make her start going back down. So I'm gonna change girl state to down. And then I'm gonna add another clause after that that says if girl state is down, I'm gonna make her go down this time, which is achieved by increasing her Y value. So she's gonna go up until her head hits 50, the 50-yard marker here. And then if it hits, we're gonna change her state to down, which means the code is not gonna go inside this conditional anymore. Instead, it'll switch to this conditional for every single frame. And when she's in the down state, she's gonna start coming back down. So let me save this code. Oh, there we go. I feel like I want her to go a little bit higher up before falling back down. So maybe, there we go. Kind of looks like she's jumping a little bit, but we want her to stop now. When she gets back onto the ground, we want her to stop. So how do we do that? We can write an if statement here to say, well, if her location now is less than or equal to canvas height minus girl height, what her location should be when her feet are touching the ground, then I want to change her state one more time back to idle, where neither of these conditionals would be true, and then she's just going to stay. Let's try that. Oops. Oh, this should be greater than or equal to. Bam! Okay. So we have a jumping ninja girl, but the jump is not very natural, is it? Oh, I can get her to jump while she's in midair. Probably shouldn't allow that. Alright, how can we disallow that? If she's already in the down state, can I? Yeah, while she's in the down state, don't change her state back to up. So her into the up state. That'll prevent her. Yeah, I can't make her jump while she's in the air anymore. Okay. Now, how can we make her jump seem more natural? Seem like it's based on the laws of physics? Well, there's a concept of acceleration, right? When you're jumping, gravity is acting opposite to your force that you're jumping. Your ascent kind of slows down gradually until at the top where you're not ascending anymore, and then you're falling back down to the earth. So that number is this number. This number is the delta, the amount that you are changing in position. So there are 10 frames for the jump. So maybe what I do is make the jump happen in precisely 10 frames. 5 frames going up and 5 frames going down. And then I will kind of set the amount of displacement, amount of movement in each single frame. Let's try that. I'll call that array the jump offsets. At beginning is -5. Is the first, and then -4. So maybe what we do now is have an index. First time index would be 0, and then I'll pick out this -5 and make the girl decrease by 5. With this strategy, we only need one state. We don't even need an up and down state. So I'm gonna just change it to, instead of idle and up and down, we're just gonna have a jumping state. So it's either idle or jumping, and if it's idle, I'm gonna change it to jumping, and then this one will just be if it's jumping. I'm gonna delete this code having to do with going down, and we don't need to change it to the down state. So while it's jumping now, it's going to displace the Y position of the girl by one of these amounts depending on this index number. The first time is going to displace by the jump offsets at jump offset index, that much. And then I'm just gonna like plus this guy. Like each time I'm gonna add 1. Actually, I kind of don't like using plus, so I'm not gonna use it. I'm gonna plus equal 1 as a separate statement, and then, but if it gets to the end of the array, that's the end of the jump, and we're gonna set the girl state back to idle. See if that works out. All right. Whoa, that didn't work the way I planned at all. Let me see. How are we gonna debug this? I'm gonna see the amount of offset at each point. So that's that one. Oh, I think I see what the bug is. I didn't put a plus here. So I wanna change girl Y here, but I didn't do that without the plus. So let me do that. Okay, that kind of worked, but it broke the second time around, and I'm not quite sure why. I do need the 5 here to make her go back to the same place. But it broke immediately. I press up to jump, it comes back down, her shoe comes back down, and I press up again. She just disappears. I don't know what's going on. To debug this, so this game loop is happening all the time, like many times per second. And I'm just gonna print out the location of the girl. All right, let's see what happens. So while it's jumping, oh, girl's Y is Nan. How did that happen? Oh, I know. The next time we need to reset the offset index at 0, because if it's not 0, it keeps going up beyond the length of this array. We will get a undefined value out of this array, and then you try to add a number to an undefined value, you get Nan. Okay, so here, after we stop jumping, we need to set the jump offset index back to 0, like that. All right, now we can jump more than once. Woo! Jumping for joy. One thing to mention is that you can see how quickly this game loop function is getting executed many times a second. And that's how the game loop works. I'm gonna get rid of that printout, so not to be distracting. I'm gonna try to get Ninja Girl to jump a little higher. So by changing these numbers, so maybe if you double all these numbers or something. Yeah, I'll double it here maybe, so I don't have to change each number. Okay, let me try to triple it. I don't have a lot of time left for this session. Let me see, what's one last thing that I want to do before I leave? I want to extract these two sections of the game loop, in particular the rendering code and the update objects code, into named functions. Okay, so I'm gonna use the refactoring feature again and say extract this function to a function in the global scope. There you go, and I'm calling this render. I'm not gonna include this request animation frame call because that is nothing to do with rendering objects. I'm actually gonna move this. Oh, I actually don't need to call this because request animation frame will call it. I want to double check. Okay, that's cool. And now that this function is called render, there's no need to write that line of comment. And I'm gonna extract this block into its own function too. Again, I'm gonna remove this line of comment because the name of the function speaks for itself. So now I have a update function and a render function. Make sure it works. Okay, so Ninja Girl can jump, and so far we have 56 lines of code. I'm gonna post the source code on GitHub. So in future episodes, I'm going to start making use of classes and objects in object-oriented programming and design patterns. And there will be a lot of refactoring. And we have already covered a lot of refactoring in the form of function extractions and variable and constant extractions. And you'll see more of that. Thanks for watching the first episode of this series. Hope to see you next time.